Right, I'm going to talk about how to build a bike generator, a bicycle electrical power generator. The reason I built mine is I was doing a lot of indoor training. I got quite a busy schedule, so I ended up training indoors quite a bit. And I thought, I'm just putting all this power through the bike, all this power into the pedals, and it's just disappearing into nothing. It's just turning into sound and heat. So I thought, if I can generate electrical power from the power I'm putting in the pedals, it just makes sense to do that. And then if I can power the laptop that I'm using to like watch videos, training videos or whatever, it becomes a completely self-contained thing, you know, that doesn't take any power. So if we end up on full zombie apocalypse, you know, I can still watch videos and train and I'll be alright, as long as I stay away from zombies. So I'll give you a look round and then we'll give you a demo. So we'll do a little walk round. That's the overview of it. See the front there, some fans, got some speakers on there. It has evolved quite a bit since I started building this. There's all kinds of stuff on it now. I'll explain what it all is. Cabling going down from the head unit down there. This is stuff being power packs being charged. There's an AC inverter down there. It's the main power section there. From the alternator, drive belt. Come around this side. Some sockets there, so it will produce 240 volts. So you can power stuff off there. And let's bring it back up this side. So let's start with the bike. The bike itself was an eBay spec. I think it was about 40 quid off eBay. Actually, I built this thing for under £100, mainly because a lot of the stuff I had knocking around from other projects, so I had all the wood anyway. I had a lot of the cables and switches and that kind of thing. I even had that pair of speakers, so a lot of it I just had lying around, and that kind of explains why some of it looks a bit haphazard as well, because I've just used stuff that I've got. So the bike, first of all, obviously the most essential bit, you need a bike that fits you. This fits me and my wife, so it's kind of a compromise between our sizes, but when you're inside it's less important to have something perfect. So what I've done is removed the tyre from the rear wheel, obviously, and I've put a drive belt on there. These you can pick up easily from any belt supply shop online. There's places that do millions and every different kind of belt you can imagine. I've used an alternator there, and this belt just fits the grooves on the alternator pulley. You can see that. One key thing is that the belt, it needs to fit whatever pulley is driving your generator mechanism, but it also needs to fit within the sidewalls, the inner sidewalls of the rim. If it doesn't, if it's a bit too wide, what happens is it squishes in between the sidewalls there, and it generates a lot of friction, and friction is bad when you're pedalling away. You want as much going into the pedals as possible. So there's nothing special about the drivetrain or anything. I've fixed the front derailleur, so it's only in the big gear. You don't need the little gears. And also I've used an alternator on there, and an alternator needs to be driven at a minimum RPM. This is 3,200, so you've got to drive it at 3,200. If you go below that, it starts wavering. It gets a bit difficult to drive and keep consistent. So I tend to use a fairly high gear most of the time, and the rest of the 3,200 RPM sounds a lot, but actually it's dealt with the big difference in the size of the pulley and the size of the wheel there. But it's worth doing some consideration when you're deciding which generating device to use. Is the minimum RPM. If you're using an alternator or an AC motor, they have a minimum RPM, and I'm going to do a separate video on the pros and cons of whether you should use an alternator like this one or a DC motor generator. There are the pros and cons to using both. For me, one of the key thing really for this one, alternators are cheap and they're easy to wire. So once you've got an alternator in, it has all the voltage regulation and rectification in there straight away, and it means that anything that's coming off the feed, the power feed from the alternator, anything that's built to work in a car circuit or use a cigarette lighter socket, they're not called cigarette lighter sockets anymore, are they? Called power sockets or whatever. But you know what I mean. It will just plug straight into it, so you don't need to think about voltage much or anything like that. Okay, so think about the RPM, and all you need to do is a bit of maths on the ratio between the pulley and the wheel size, and generally that step down gives you a big step up in RPM. So if you're turning this at 100 RPM and you look at the difference in size of that, then it's going to step it up quite a bit. I might do a separate video on exactly how to calculate that, but there's plenty out there about that kind of thing anyway. Okay, so power goes through the pedals, through the drive belt, and it turns the alternator. Alternator is fixed pretty securely down to the wood. Reason is, once you start pedalling, this pulls the drive belt and it will pull the alternator up forward. Once there's resistance on the alternator, it's going to pull it forward. So that needs bolting down nice and securely. Here's a 12-volt battery. One of the things to remember about an alternator, or in fact any AC motor, if you're using it to generate power, is that you need to put a small voltage in to begin with to get it started. It's got a field coil in there which starts the electromagnetic process of energy generation inside the alternator. A bit more about that on the other video, but you do need a tiny voltage just to get it started, and then it generates its own power after that. So you will need a battery. If you use an alternator, you will need a battery in the circuit. The other good thing about this, it's a 4 amp hour battery, so it's not very powerful, but it does act a bit like a buffer. So once you switch more stuff on in the circuit, this just acts a bit of a buffer until you start putting more power through the pedals. So a really good thing to mention, if you don't know about it already, is that the reason this is so good to use as a training aid is that the electrical load on the alternator means greater resistance to turn the alternator pulley, which translates to you need to put more power into the pedals. So you can set it up as I've done with various switches to switch things in and out of the circuit, which will give you more of a power draw. So you can start off low, warm up, and then connect more and more things into the circuit, charge more and more devices, and you'll end up, you'll need to put more and more power out. And you can have a variable resistor to adjust it and all that kind of thing. A bit more about that in the more technical videos. So what I've got there is a master switch, and that switches the battery on and into the circuit, and it also allows the field coil to be activated. The reason there's a big power switch down here is that it stops any drain from the battery through the field coil, because it will drain off very slightly if you leave it connected. It also switches on this volt and ammeter down there. So we've got volts on the top, amps on the bottom. So it's reading at the minute, that's reading the battery voltage at the minute, 11.3. When we switch it on and start pedaling and we get the alternator going, you'll see that go up to about 14.3, 14.4 once it's coming out of the alternator. And the bottom 0.1 amps, that's just what that's reading is the drain through the field coil of the alternator. So that's just coming off the battery. This also is a master switch for the whole circuitry. So down here we've got standard car, plugs and sockets on there. Nice and convenient to use. I had a load of them knocking around. You don't necessarily need to do that. You could wire it in and solder it in. You don't need the plugs. But I had these knocking about, and I thought it was good, so I could make it modular and I could adapt it as I went along. As to use these things, because I can take stuff out, plug it in. I've got these onto a splitter, so I've got 3 more sockets, which I've got various different things plugged into there. And there's another circuit which comes off here, which goes to the inverter. Now what that inverter does, obviously this alternator chucks out about 14 volts, so any something that's designed to run in a car on a 12 volt circuit it will tolerate up to 14 volts usually if it's designed to work in a car. This switches it up to 240 volts and AC, so it goes back to AC, and that runs on a cable out to the back here, and I've got 3 AC sockets. You can see one thing's plugged into that already, and we're going to use that on the demo. That's actually the amplifier at the front. And what it just makes it more versatile, so you can plug stuff that's a bit more powerful in there. You've just got to remember that there's a limit to how much power you can put out, if you plug too much in, you'll either blow a fuse that's in one of these sockets, or if you have really high power fuses, you'll just get to a point where you can't pedal anymore. But it's great to see just how much you can actually do, and I'm going to do another video about boiling a kettle, because that should be fun and extremely hard, I imagine. So moving through on here on the wiring at the bottom, this I've got an adapter there, a power pack. This actually runs the fans which are up on the top, and it also means I can power any laptop. So I've got different connectors that go into that. It will power pretty much any laptop or tablet device that you want to use for watching videos or whatever while you're pedaling away. And that side, that's the power pack that runs the amplifier. That runs up, there's a USB hub there. I've got a couple of fans plugged into that, and there's also a spare USB for charging a phone or whatever. These other DC circuits run into here, which is charging power banks. So I had a few power banks already, which is why there's an array of different ones. But these allow fine adjustment of the electrical draw. So you can plug some of these in and take some of them out. Some of them are quick charge, so they take a couple of amps, which means it's giving you something to pedal against basically. And I've just built a little box to put the power banks in so that I can charge them up. And then I use these when I go away camping or on expeditions or I go travelling. I use these for that kind of thing. So I've charged them up using my own steam, if you will. Got a speed and cadence sensor on there so I can track speed and cadence, obviously. I haven't got a power meter on yet. I do intend to put a power meter on, but as you can see, these cranks aren't exactly the most modern cranks in the world, so I might need to do something about that before I put a power meter on there. But it will be interesting to see what power I'm putting out versus the amount of electrical power I'm generating. So if you multiply these two things together, you multiply volts and amps together, you get power in watts. So I reckon that the alternator is running at approximately 50% efficiency, and there are also some other efficiency losses just in friction of the system, the drive belt and the chain and that kind of thing. So it will be interesting once I get a power meter to do a proper comparison. Couple of loudspeakers, they're in the shade a bit, aren't they? But yeah, a couple of speakers on there. Reason is I just thought it'd be cool really to be able to power music by the power of the pedal, and also if I want some tunes blasting out give me some motivation while I'm pedaling, then that works. The amplifier is a little one just stuck to the side there, so that's Bluetooth, so I can connect a phone to it, or it'll plug into a laptop or a tablet or whatever using the cable on there. That was a nice little addition. Here's the control centre, so I've got some fans there and another little one down there. That is otherwise known as the testicooler, just because of where it sits. This is just a light switch box, and it's got cabling which runs from the back all the way down here. I've just tied it on there, and that comes down to here, and it basically plugs into these junction boxes so that everything can be switched from the cockpit, if you will. So if I want more or less power, I can switch it from up there instead of having to get off and adjust anything or plug anything in or plug anything out. So you can see there's a switch here, that's for the field coil, and that's what gets it started. So you press that, turn that on, turn it off, and that gets the alternator generating power. That's the DC master switch. That switches on the power pack and runs the fans, and it also means that these two sub switches will then operate So you can have two different things connected onto there, two different loads. There's also the AC master switch. So that switches on the inverter and allows you to run mains powered equipment from that. And just zooming out a bit, you can see these are fans. These are just USB fans that connect in to this USB hub down there, which runs off that power pack at the front. Coming around here to the front, a bit of a squash by the window. This is just at the back. So the main construction is MDF, and I've used MDF mainly because that's what I had lying around, but it's also pretty cheap. If you're buying wood, it's pretty cheap to buy some MDF, and it works quite well. So this is inch thick stuff. This is just, I had inch thick stuff knocking around. You probably don't need quite so bulky wood to do it really, but that's what I had. The base needs to be nice and strong. So I've got the bike on, this is from an old mag trainer. So this is just clamped in there. You can see they're just the standard clamps, and I've taken off. That had the old mag set up on there, which just had the thing that rubs against the tyre on there. So I just took that off, and there's enough clearance there for the belt. So it's worth thinking about that when you're mounting your alternator or whatever. You need clearance for the belt at the bottom. If you don't have one of these, you can pick them up dead cheap. You can get a cheap one really off eBay. The mag thing doesn't need to be any good. All you need is the stand. So you can get them for not a lot of money. eBay, AliExpress, that kind of thing. MDF base, nice and solid. It does make it pretty heavy using inch thick MDF to move it around, so you could probably get away with less than that. It depends how much you need to move it. If you're putting it in a garage and it's never going to get moved, it doesn't really matter. I've got it on a cloth here just to protect the kitchen floor. So that is the overview really. That's how it's set up. Probably time for a demo, I think. Okay, we're going to do a quick demo. So the first thing to do is to start pedalling and spin the alternator up to speed. So as I mentioned before, it needs to run in at about 3,000 RPM or more before it will generate power stably. So the gearing takes care of the speed. You don't need to worry about that as long as you set the gears up properly. So start pedalling, and then there's an ignition switch on the dash which starts the alternator generating power. So I'm going to flick that, and we're going to show you the voltmeter, and you'll see the volts will go up to about 14.3, 14.4 once it's generating power. And then I'm going to press the master switch, which just switches the fans and the USB ports on, and you'll see the current go up. So the volts are the red figure, the current amps is the green figure. You'll see the green go up a little bit when it's generating power, because that's just putting some power back into the battery. So here we go. So this is the field coil engine. So we're generating power now, and I'm going to switch the master switch on now. Okay. So you can see we've got fan action going on. Absolutely critical with an indoor trailer, as anyone who's ever done any indoor training will know. And you can see it's generating about an amp of power at the minute. So it's nice and easy to pedal, not a problem. So just to give you a good demo that you can see about kind of what it can power, I'm going to switch the inverter on. I'm going to run the amplifier, which is connected, as you can see there. It's connected to the laptop, which is just playing some music. So I'll switch the inverter on, and you'll see the power will jump again. So the amplifier is switched on, turn the volume up. that is just being generated from the bike. I can also plug this in. If I plug that in, that will start charging the laptop as well, so it will make it fully self-sufficient. So let's put this in as a final bit, and you'll see the current will jump up quite a lot because it takes quite a bit to power a laptop. Okay, so to stop generating, you just need to make sure you switch the stuff off before you stop pedalling. Otherwise it will try and suck too much power out of the battery and you don't want that, unless you've got a big battery on there. So that's off, and then stop pedalling. So the current that's going into the battery, or any remaining circuitry, will act like a brake on the alternator. Bit out of breath, mate. So it will stop pretty quickly. If you just pedal as it is, see, it takes longer to stop because there's no resistance on the alternator. And that just gives a clue as to how it can work as a training aid, because you can put more load on there and that acts as a stronger brake on the alternator. Okay, I hope that's been useful. As I say, I'm going to do a couple of other videos on more technical aspects of it, like alternators versus DC generators, and exactly how to do the circuitry and that kind of thing, and maybe how and why it works if people are interested in that. If you'd like to give it a like, that'd be really good, because it'd be useful to know if anyone's interested in this, and so, you know, could put more stuff on or whatever. That'd be nice feedback. Thanks for watching.